This integral is not easier. Sine fourth and cosine fourth in the denominator. Now this is the way I'm doing. This is equal to integral dx over this is if I use a binomial, this is a sine square x plus cosine square x square. Then I take away the middle term, right? Minus twice sine square and a cosine square. Yeah, that is obviously equal, right? Then this is equal to integral. Now this is 1, right? This is 1 minus sine square is sine x cosine x. There's x here. Sine x cosine x is half the sine 2x. Therefore, after square it becomes half sine square over 2x. Alright, this is dx. Well, it seems not very clear. Well, let me write it bigger. So this one is equal to, this is sine square 2x, and that would be equal to 2 sine square x cosine square x. And then I multiply by 2, both top and bottom. See, there's 2 dx. Let me write it bigger. This is 2 minus sine square 2x. Well, that's better. Okay, good. What then? Then I change this one into sine and cosine. This is this will be 2 sine square 2x plus 2 sine square 2x. So this becomes the leftover is 2 cosine square 2x, right? Plus sine square 2x and 2 dx. Well, is that clear? Okay. 2 is a 2 cosine square and a 2 sine square, and after minus sign becomes this. Yeah. Then I divide everywhere by 2 cosine square 2x. So this becomes 1. This becomes half tangent square 2x. 2x. Yeah, on top would be divided by 2, right? Secant square. So this is 2 secant square 2x dx. Well, I think everything should be okay. And this one is equal to 2 cancel out, right? 2.5 cancel out. This is equal to 1 plus square root 2 and tangent 2x all together square. That is this. And on top would be the derivative of this square root 2 tangent 2x and this will be 1 over square root 2 times secant square 2x times 2. So after cancellation, you left over another 1 over square root 2. So that will be equal to this. Okay. So the result will be equal to 1 over square root 2 arctangent square root 2 and tangent 2x plus c. That will be my result. Okay, well, I'm sorry that the writing a little bit smaller, but I hope you can follow. Well, this is a very nice way to integrate. Thank you for your watching.